Have a look at this calculus problem. This is from JEE Advanced 2017, and it says that f is a differentiable function, and it's an inequality is given saying that the derivative at every point is greater than twice the value of the function itself, and a boundary condition is given that f of 0 is 1. We need to find out if f is decreasing or increasing in the interval 0 to infinity, and further, if possible, we need to find out if the function, the derivative of the function f dash of x, if it is bounded by the exponential function in this interval. Okay, so let us start off by having a look at this inequality. Now, one thing which you may feel that that needs to be done is simply take the integrals on both sides and then do the problem. But that's kind of it's fine, but you need to do some kind of you need to assure that the functions are both positive and so on if you want to take the integrals on both sides and then do. A better way of doing the problem is to try to write this inequality as the derivative of another function and then conclude that that particular function is increasing. So what is that particular function? Have a look at here. So we have f dash of x greater than twice f of x. So which means we can write it as f dash of x, it is so f dash of x minus twice f of x is greater than 0. Okay, all right. Now let's have a look at this particular thing. Can we write this as the derivative of another function? So in other words, can we write this minus 2 over here as obtained as a derivative of some particular function? Yes, we can, if we take e power minus 2x, right? Okay, so which means if I multiply both sides by e power minus 2x, then what happens? So this is a positive function, so therefore multiplying won't change the sign of the inequality. Now it's like taking the derivative of the function e power minus 2x times f of x. Okay, because this is the derivative of f, and then the next term, that is minus 2 times this, will be taking the derivative of e power minus 2x. So that means the LHS can be written as d dx of e power minus 2x times f of x. And it says that this derivative is always greater than 0. So what does it imply? It implies that e power minus 2x f of x, this function is strictly increasing. Okay, so if this is increasing, can we say that f of x is as in one of these things? Can we choose? Now let us make use of the fact that f of 0 is given to be equal to 1. Okay, so which means if you call this as g of x, okay, if we call this as g of x, now what it says is g of x is strictly increasing. So and further let's see what is the value of g of 0. So we have g of 0 to be f of 0, which is given to be 1, and this again is 1. So we have g of 0 is 1, and we have g of x is also increasing. So which means for any value if in the interval 0 to infinity, which implies g of x will be greater than 1 for all x in the interval 0 to infinity. Okay, because of the increasing property. So what is g of x? Which means f of x e power minus 2x, which can be written as upon e power 2x, is greater than 1 for all x in this interval. Or in other words, we can say that f of x is greater than e power 2x in the interval 0 to infinity. So this is the right way of approaching the problem, that of trying to write it as the derivative of a function and then concluding that the function is bounded below by e power 2x. Now moving on to the whether f of x is increasing or decreasing. For that, actually this does not matter. We can straight away conclude using this particular thing itself. So what does it say? It says that f dash of x is greater than twice f of x, and further it is given that f of 0 is given to be equal to 1. So which means f dash of 0 is greater than 2. Okay, f dash of 0 is greater than 2, so f is increasing there, and which means as the value of x is increasing, the value of f it also is increasing, or in other words, f itself is an increasing function. Okay, so the right options over here are f of x is increasing in this interval, and further we can conclude that f dash of x is greater than e power 2x in 0 to infinity. So this was a nice problem wherein it was not explicitly mentioned about f of x, but you were asked to conclude such things by introducing this e power minus 2x factor.